Hello guys, this is Mr. Makokha Fredrick Matseshe again. Welcome back. And for our case, we have a question under sequence series. A question says the sum of the fourth and the sixth terms of geometric series is 80 if the product of the third and the fifth is 256. Determine Roman 1 first term, the common ratio, and the third sum of the first 8 terms. Now under solution, this is, you can remember, if it is geometric series, this is a GP. Now in a GP, this is called geometric progression. You have the nth term. To get the nth term is given by the formula AR raised to n minus 1. And here now we follow this formula. We have the fourth term, which is equivalent to AR raised to 3 when you follow this formula of the nth term in a GP. And the sixth term is equals to AR raised to 5. So the n was here, the n is 4. Now n minus 1, which is 3. Here n is 6. N minus 1, which is 5. And we have, secondly, the third term, which is by the formula, from the formula AR raised to 2. Then the fifth term is equals to the expression A raised to 4. Now we have, they said, the sum of the fourth and the sixth, the sum of this and this. Now the first equation will be AR raised to 3 plus AR raised to 5 is equals to 80. This is the equation 1. And equation 2, and equation 2 we have this one. The product, they say the product of the third and the fifth is 256. So the product of the third, which is that one, multiplied by AR raised to 4 is equals to 256. This is equation 2. Now from equation 2, let us make A as the subject. Make A the subject of the formula. So AR squared multiplied by AR raised to 4 is equal to 256. Let us, from this equation 2, let us make A the subject of the formula. Now we have, when you multiply, it is A, follow the law of indices. A multiplied by A, it is the same as A raised to 1 multiplied by A raised to 1. So you add the power, so it will be A squared. What about R raised to 2 multiplied by R raised to 4? In terms of law of indices, you add the power to be R raised to 6, which is 256. Good. Now let us make A squared is equals to, divide both sides by R raised to 6, R raised to 6. It will be 256 all over R raised to 6. Now we have A squared is equals to 256 all over R. To get A alone, because we need to make A, not A squared, to be the subject. Now we square root both sides to have A is equals to, when you square root this one is 16, then when you square root this one it will be R raised to 3. Then substitute A as 16 over R raised to 3 in equation 1. And equation 1 was A R raised to 3 plus A R raised to 5 is equals to 80. Now let us substitute A as this. So you have 16 over R3 multiplied by R raised to 3 plus 16 over R raised to 3 multiplied by R raised to 5 is equals to 80. So you have this one and this one you cancel. This one, and you divide our indices, these indices following the law of indices. R raised to 5 divided by R raised to 3. It means you will subtract the power. So it will be 16 plus 16, it will be R raised to 2 now, is equals to 80. So you have, when you take this one to the other side, it will be 16 R raised to 2 is equals to 64. Now you have R raised to 2. You divide both sides by 16. R raised to 2 is equals to, when you divide this one, it will be 4. But we want to get R particular, so you square root both sides. So R particular is 2. Now, if R particular is 2, we say now the common ratio, it is the common ratio R, which is 2. This is the answer for part 2 of the question, Roman 2 of the question. Now, but A was 16 all over R raised to 3. Here we substitute R as 2. So you get A as 16 all over 2 raised to 3, which is 16 over 8. So A, which is the first term, first Roman, the answer now, it will be A is equals to 2 again. Then the last part, which is Roman 3, we have summation. They said the sum of the first 8 terms, which means you use the formula, it is under GP. The formula, you have two formulas here. We have Sn is equals to A into R raised to n minus 1 all over R minus 1, where R, we use this formula where R is greater than 1. But when R is less than 1, we have the formula Sn is equals to A into 1 minus R raised to n all over 1 minus R, where R is less than 1. So for our case, R was 2. Now if R was 2, here now we use the first formula because R is greater than 1. So we implement the formula, or we use the formula in simple terms. We use this formula. Sn is equals to A into n raised to 1, R raised to n minus 1 all over R minus 1. So we say, let us substitute. It is summation of 8 terms is equals to 2. A is 2, R is 2 again, raised to 8, because they said 8 terms. So the number of terms is 8 minus 1 all over 2 minus 1. 2 minus 1 is 1. So now the summation, when you simplify this one, it will come to, you will get your answer as the sum of the first 8 terms S8 is equals to 520, and that is all about that question. This is the answer.